Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the Mango Bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.
Hello, graded students. Welcome to another learning episode in Grade 8 Mathematics. I am Mrs. Theresa P, your learning buddy. So I want you to sit back, relax, and enjoy. For here at Carlos and Carlin Network, Math Sayang Matuto. Our topic for this lesson is all about illustrating the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of a statement. This is taken from Quarter 2, Week 8, Module 12. What are our learning objectives? First, let us identify the truth value of the converse, inverse, and contrapositive of a statement. Number 2, let us show the equivalences of A, the statement and its contrapositive, and B, the converse and inverse of the statement using the truth value. And lastly, relate the equivalences of statements in real-life situation. Last time, we discussed the conditionals or if-then statements and its kinds. So, I want you to use these hand signals for you to easily remember them. So, if P, then Q. That's if-then statement. How about its converse? You just interchange the positions of the hypothesis and the conclusion. So, if Q, then not P. Let's have the third one, the inverse. Just negate the hypothesis as well as the conclusion. So if not P, then not Q. How about the fourth one, the contrapositive? You just interchange the positions of the inverse. So if not Q, then not P. Okay, so let us form an if-then statement using this picture. So, if you own a dog, then you are an animal lover. How about its converse? Yes, what's in your mind is correct. If you are an animal lover, then you own a dog. How about its inverse? If you do not own a dog, then you are not an animal lover. How about its converse? So, if you are not an animal lover, then you do not own a dog. I want you to observe this two statements. If you own a dog, then you are an animal lover. The second one is, if you are not an animal lover, then you do not own a dog. So, if you are an animal lover, it follows that you also love a dog. Or if you own a dog, then you are an animal lover because a dog is an animal, right? So do they mean the same thing? Yes. And what do you call them? Yes, they are called equivalent. So, the state or property of being equivalent is called equivalence. Meaning, if one statement is true, its equivalent statement should also be true. Likewise, if one statement is false, then definitely its equivalent statement should also be false. Okay, and the property of being a statement of being true or false is called truth value. We use letter T to denote true and letter F to denote false. And when these truth values are put into table, that's called truth table. Now, when do we know that a conditional is true or false? Take note of this. A conditional is false only when an example can be found where the hypothesis is true, but the conclusion is false. Okay? So from that concept, we will be forming 4 different combinations for the hypothesis and the conclusion. And each combination is called implication. Okay? For our rule 1, if the hypothesis is true and the conclusion is false, then the decision for that implication is also true. And for rule 2, if the hypothesis is true, but the conclusion is false, then the decision for that implication is false. For combination 3, if the hypothesis is false, but the conclusion is true, still that implication is true. And for the 4th combination, if both hypothesis and the conclusion are false, then that implication is true. Okay? I want you to observe the decisions for the 4 implications. Only one is false. As what we have mentioned, that a statement is false only when the hypothesis is true, but the conclusion is false. Now, let us have the truth tables of an if-then statement. Let us consider the statement, if you own a dog, then you are an animal lover. Okay, let's have step 1. Let us identify the hypothesis and conclusion. So what's the hypothesis? Yes, you're correct. You own a dog. How about the conclusion? You're correct again. You are an animal lover. Let's have step 2. Let us state the implications following the format. Okay? Take note that this format is taken from our truth values before. So, if P, then Q. The second one, if P, then not Q. The third one, if not P, then Q. For the 4th one, if not P, then not Q. Let's have step 3. I want you to listen intently to this. If a part has the same thought or words as the original part, then its true value is true. But if a part has a thought opposite of the original, then the truth value is false. Okay, let us again be guided by this format. So, putting that for that implication, first, if you own a dog, then you are an animal lover. The hypothesis, as you can see, did not change the thought. has not changed the thought. So, it's true. The same is true with the conclusion. It has the same thought as that of the original. So, what is our conclusion? What is the decision for that implication? It's true. And we use rule 1. For the second implication, if P, then not Q. If you own a dog, the hypothesis, yes, the same thought as the original part. Look at the conclusion. You are not an animal lover. So, it's opposite of the original. So, what is the conclusion or what is the decision for that implication? It's false because the conclusion is true. Even the hypothesis is true, but the conclusion is false. The decision for that implication is false. Let's have number 3. If not P, then Q. So our hypothesis is opposite of the original. So it's false. Look at the conclusion. You are an animal lover. It's the same as the original. So it's true. So if the hypothesis is true, is false, but the conclusion is true, is still that implication is true. That is rule 3. And for the fourth one, if not P, then not Q. So our hypothesis, if you do not own a dog, has the opposite thought. So it's false. Our conclusion, then you are not an animal lover. Also, it has the opposite thought. So, what is the decision? It's true. Because both the hypothesis and the conclusion are false. Alright. Let's have the truth values of the converse of an if-then statement. So step 1, let us state the converse of the original statement. Okay, let us first have the original statement for you not to be confused. If you own a dog, then you are an animal lover. Then let us state the converse. If Q, then P. If you are an animal lover, then you own a dog. Next step is to identify again the hypothesis Q and conclusion P of the converse statement. So, if you are an animal lover, then you own a dog. What is our hypothesis? Yes, you're correct. You are an animal lover. What is our conclusion? You own a dog. So, that's the hypothesis and the conclusion. Okay, so let's have step 3. State the implications following the formats illustrated. So again, let us be guided by that format. If Q, then P, because they are interchanged. For the second, if not Q, then P. For the third implication, if Q, then not P. For the fourth one, if not Q, then not P. Alright, let's have the following table. So, implication 1. If you are an animal lover, so our hypothesis does not change as the thought of the original one. So, it's true. Our conclusion is you own a dog. So, still, it has the same thought. So, it's true. So, our conclusion or our decision is true. And we use rule 1. For the second implication, if not Q, then P. So, our hypothesis, you are not an animal lover. Take note of the word not. It opposes the thought of the original one. So, it is false. Our conclusion, you own a dog. It does not change. So, it's true. What is our decision? It's true. False, true, true. We use rule 3. For the third implication, if you are an animal lover, then you do not own a dog. So our hypothesis again does not change its meaning. So it's true. But look at the conclusion. You do not own a dog. It has an opposite thought of the original. So it's false. So again, if the hypothesis is true, but the conclusion is false, then our decision is false. And the rule we used is 2. For the fourth one, if you are not an animal lover, that's the hypothesis, take note of the word not. It's false because, yes, you're correct, it is opposite as that of the original. Our conclusion, you do not own a dog. It is also opposite to that of the original. So, it's false. So, what is our decision for the implication? If both the hypothesis and the conclusion are false, then the statement is true. And we use rule number 4. Okay. Next, let's have the truth values of the inverse of an if-then statement. So step 1 is state the inverse of the original statement. Okay? If you own a dog, then you are an animal lover. And let us have again the inverse. If you do not own a dog, then you are not an animal lover. Again, what is our step 2? Yes, you're correct. Let us identify the hypothesis, not P, and conclusion, not Q, of the inverse statement. So, for this one, what is our hypothesis? You do not own a dog. And our conclusion? Yes, you're right. You are not an animal lover. Alright, let's have step 3. Let us again state the implications following the format illustrated here. Here's the format as our guide. So, if not P, then not Q. If not P, then Q. The third one, if P, then not Q. For the fourth one, if P, then Q. Okay, let's have the table. Okay, the truth values of the negation of the original hypothesis and conclusion will be the truth values of the inverse statement. Okay, because an inverse statement is just the opposite. So, the truth table for this is very easy to identify. Just negate the truth table of the if-then statement. It's here. So if you do not own a dog, then you are not an animal lover. So false for the hypothesis, false for the conclusion, and if both the hypothesis and the conclusion are false, then definitely the implication is true. That is rule 4. Next implication, if you do not own a dog, then you are an animal lover. So the hypothesis is false because of the word not. And the conclusion is true because it's the same as the original. So therefore, the implication is true. And we use rule 3. For the third one, if you own a dog, then you are not an animal lover. So our hypothesis did not change, but our conclusion has the word not. It opposes the thought of the original. So again, if the hypothesis is true, but the conclusion is false, the implication is, yes, you're correct, it's false. That is rule 2. For the fourth one, if you own a dog, then you are an animal lover. Our hypothesis is true. It's still the same. And our hypothesis, our conclusion is also the same as the original. So they are both true. And if the hypothesis and the conclusion are both true, then the implication is true. And we use rule number 1. Okay? So let's have the fourth truth values. That is the contrapositive of an if-then statement. Again, let us state the contrapositive of the original statement. And to do that easily, let us first state the original statement, if-then statement. If you own a dog, then you are an animal lover. So what is the contrapositive? If you are not an animal lover, then you do not own a dog. So step 2, yes, you could easily do this because you will just identify the hypothesis and conclusion of the contrapositive statement. Let's do it. So what is the hypothesis? You are not an animal lover. How about the conclusion? Yes. Exactly. You do not own a dog. For the step 3, it's state the implications following the formats illustrated. Let us be guided by this. If not Q, then not P. If Q, then not P. If not Q, then P. And the fourth one is if Q, then P. Okay. Look at this. The truth values of the contrapositive statement is the interchange truth values of the hypothesis and conclusion of the inverse statement. Alright. So, here is the truth values of the contrapositive of an if-then statement. The table. So, if you are not an animal lover, the hypothesis is false, right? Because of the word not, it opposes the original. Our conclusion, you do not own a dog. Not, there is a word not again, it opposes the original. So if both the hypothesis and the conclusion are false, then the implication is true. That is rule, yes, it's 4. For the second implication, if you are an animal lover. So what is our hypothesis? It's true, right? Because it's the same as the original. Our conclusion, you do not own a dog. It opposes again the original. So it's false. So what is our decision for the implication? It's false. And we use what rule? It's number 2. For the third implication, if you are not an animal lover, that's the hypothesis. Is it false or true? It's false because of the word not. It opposes. It negates the original. Our conclusion, then you own a dog. It has the same thought as the original, so it's true. So if the hypothesis is true, but the conclusion is false, but the conclusion is true, then the decision is true. And that is rule 3. For our fourth implication, if you are an animal lover, then you own a dog. Take note, both the hypothesis and the conclusion do not change the thought of the original. So, they are both true. And if the hypothesis and the conclusion are both true, then the implication is true. And what rule is that? Rule 1. Okay. So let's have the summary table of truth values. The summary table of the if-then statement, the converse, the inverse, and the contrapositive. I want you to observe the 4 truth values. So let's have the original statement or the if-then statement, true value. True, false, true, true. which among the three is the same as that of the if-then statement? Yes, you're correct. The contrapositive. True, false, true, true. Look at the converse truth value. True, true, false, true. Is it the same as that of the inverse truth value? Yes. Okay. So, if the original statement or the if-then statement has the same truth value as that of the contrapositive, then what do we call them? We call them? Yes. Can you remember that? The one that we mentioned a while back? That they are equivalent. Or they are logically equivalent. Look at the converse and the inverse. They have the same truth values. That's why they are also called logically equivalent. Okay. So, again, what do you call the given if-then statement and its contrapositive? They are called logically equivalent. And why? Because, yes, you're correct. They have the same truth values. And how about the converse of a given if-then statement and its inverse? They are also called logically equivalent. And why? Because they have the same truth values. So let us apply what we have learned. So let us determine the equivalent statement of the conditional. If a polygon is a square, then it is a quadrilateral. So what is the equivalent statement of the original if-then statement? It's contrapositive. So we will be forming the contrapositive. Okay, I'll give you time. Yes. So our answer, let us see. If a polygon is not a quadrilateral, then it is not a square. Let's have the second one. Second question. Given the if-then statement, if a number is even, then it is divisible by 2. So what is the equivalent statement of if a number is divisible by 2, then it is even? Okay? What is the answer? Yes. If a number is not even, then it is not divisible by 2. Do you have the same answer as that of the correct one? Very good. All right, so I want you to get your pen and paper and let us answer the following questions. Number 1. Which of the following pairs of statements are equivalent? A. Conditional and inverse. B. Conditional and converse. C. Converse and contrapositive. D. Conditional and contrapositive. And the correct answer is, what's your answer? Is it the same as this one? Yes, it's letter D. Very good. Let's have number 2. Which of the following best describes equivalent statements? A. If one statement is false and the other is true. B. If one statement is true and the other is false. C. If both statements have undefined truth values. D. If statements have the same corresponding truth values. And the correct answer is, yes, letter D. Very good. You got it right. Question number 3. What decision can you make to an implication of an if-then statement if the hypothesis is true and the conclusion is false? A. False. B. True. C. Undefined. D. Absolutely true. Yes, it's letter A. It's false. How about number 4 question? Given the if-then statement, if an animal barks, then it is a dog. Your friend claimed that the statements, if an animal is a dog, then it barks. And if an animal does not bark, then it is not a dog, are equivalent. What would support his claim? Letter A. If the statement and its converse are equivalent. B. Converse and inverse of an if-then statement are equivalent. Or letter B. If the statement and its contrapositive are equivalent. Letter C. Converse and inverse of an if-then statement are equivalent. And letter D. Converse and contrapositive of an if-then statement are equivalent. Okay, it's letter C. Okay, very good. And let's have the last question. Given the if-then statement, if today is Saturday, then it is a weekend day. Which statement is equivalent to its converse? A. If it is a weekend day, then today is Saturday. B. If it is not a weekend day, then today is not Saturday. Letter C. If today is not Saturday, then it is not a weekend day. And letter D. If today is Saturday, then it is not a weekend day. Okay? Let us now have the correct answer. It's letter C. Very good. You got it right. So, thank you, graded students, for watching.
Good day, Philippines. Hello, Region 1. Aloha, San Carlinian learners. Airing live from the mango bamboo capital of the Philippines, San Carlos City. You're tuning into CCN Broadcast Center, a virtual home of every SDO-SEC learner, where passion is the key. Learning paves the way. With our division mantra, developing creativity, maximizing versatility. This is your CCN Broadcast Center. CCN Broadcast Center, a virtual home of every SDO-SEC learner.